Okay, so this next one will cover distance and a little bit of midpoint. Distance is going to be our focus, of course. We'll start with that. So distance or length between 2 points, um, or length of a segment. Okay, it'll work for either one. All right, they're pretty interchangeable. So I'm just going to pick two random points here. Okay, we'll call them A and B. The way I like to start with this is explaining the Pythagorean theorem and the use of that. So we want to know the length of the straight path from A to B, right? So what we first do is come straight across and straight down to create a right triangle. Now, this length from A to B is longer than this distance from here to here, okay? But it's going to be shorter than going from here to here, right? You've heard the shortest distance between 2 points is a straight line. Well, if you go straight from here to here, it's quicker than going across and up, okay? How much closer? Well, we use what's called the Pythagorean theorem, okay? There is a distance formula using the coordinates, but really, it's just based on the Pythagorean theorem. It really is, and I'll show you that in a minute, okay? So what I would do is I would count the length of this across. 1, 2, 3, 4, 5, 6, 7. I got 7. And up and down. Okay, you're changing y. 1, 2, 3, 4. Now this is exactly what I did for slope. The reason I like doing it this way is then you don't need to learn two different methods for two different problems. We're going to make our right triangle, and instead of doing rise over run, we're going to then use the Pythagorean theorem, which is a squared plus b squared equals c squared. Okay, this is the d, or distance, that we're looking for, right? It doesn't matter which one you pick as a. I'm going to pick 4. Okay, that's one of the legs. 4 squared plus 7 squared. Whoops, my formula is wrong. I'm sorry. I have a plus sign there. It should be an equals. Get rid of this. It is equal to c squared. So I'm going to replace the hypotenuse with d for distance, so d squared. All right, let your calculator go ahead and do this. 16 and 49, that's 65. Now, I like to show my work. I'm going to square root both sides, okay, and then whatever the square root of 65 is. It's a little more than 8. If it says round, you can. If it doesn't, let's assume we just need to leave it as a number in simplest radical form. So that's distance right there, okay? That's what I want to see you do. That's the best method. Now, what I could do is show you the formula, but I really hope that showing you this is only going to make you familiar with it if it ever shows up. So it's d equals, it's a big square root. It's going to look complex, but I'm going to explain it in a minute. All right, x1 minus x2 squared plus y1 minus y2 squared, quantity squared. Okay, so that's the distance formula. And if I were to give you 2 points, here's what I mean. Here's what it would look like. Let's say C is negative 5, 1, and D, we'll just make this up here, is 1, 4. Okay? Here's what it would be. You'd have to understand that that's x1. That's y1. This is x2, and this is y2. Now we write this crazy formula, okay, which I'll show you is not necessary in a minute, but we could write this crazy formula, sub in, okay, I'm going to sub in negative 5, take away 1 squared, plus 1 take away 4 squared, and you could let your calculator do it, or I could just show you a couple steps here. When we square negative, remember it's got to be in parentheses. Little side note, you know, if you square negative 3, it's positive 9 because the negative gets squared too. If you do this, this is wrong, you know, because you're only squaring the 3, not the negative, so it stays negative, okay? So be really careful what you mean to do here. All right, so that's going to be Positive 36, positive 9, it's going to be square root of 45. Now, how could we have done that without the formula? This is what I wanted to show people. Same problem without the formula. So I locate C over here at negative 5, 1. I locate D at 1 right there. Okay? So then straight path from there to there. The way I did it in the last problem was we're going to get basically your distance across. We're going to count the squares. 1, 2, 3, 4, 5, 6. Now you're going to notice, technically that's like saying, you know, what's x1 minus x2? How far apart are x1 minus x2? That's the absolute value symbol. 6 apart, right? Instead of getting negative 6, I'm going to count. So that's 6 apart. Okay? From here to here is how many steps? It's 3. Well, that's really saying how far apart are y1 and y2. Okay? And you're going to see the similarity here. It's pretty close. Okay? Now, when we go with a squared plus b squared equals c squared, we're going to call that d. Sorry. So that's going to be d. So a is, oh, I don't care. We'll say 6, right? Replace it. So you get 45 equals d squared. It almost looks like the same thing except the square root sign. Well, guess what? Now we square root both sides to get rid of the squared. That's the inverse of squaring. So we do arrive at the same answer either way. Square root of 45. Now, I wanted you to see that to realize, because somebody will show you this formula. The formula is nothing more than a specific way of doing the Pythagorean theorem. You're better off just going with the Pythagorean theorem. Now, how do they really get us away from the graph? Well, one year they threw this kind of problem at us. Look at that. We're not going to be able to fit that on the graph. That's basically where I'm going with this, okay? I don't know. We'll go with 11. All right. So basically, here's what we got. No chance at graphing that, right? So here's what we have to understand. In your mind, you still have to realize it is this, okay? It is still going to be a right triangle setup. Think of this as your change in y, and this is your change in x. How far apart are the x's? Okay, the x's are 45 apart. Right? From 42 to 3 is 45 as far as a change in x. As far as a change in y, we have 4 up and down. So, right, from 7 to 11 is 4. So we really don't need the graph if we understand the concept of Pythagorean theorem and right triangles. All right, so we're going to say again, here we go, a squared plus b squared equals c squared. There's d for distance. 4 squared plus 45 squared equals d squared. Let's see. Yeah, can't do this in my head, can I? No, let me get a calculator quick. Actually, I think I got it. This should be 2025. That should be 16. Let's see. That's 2041, right? And then the square root of 2041. Let me just double check that, though. Okay, so 45 squared. Oops. Yeah, that was right. And then if you actually estimated this, let's say we typed it in a calculator, you would get right around 45.1774, some other stuff after that, right? Sorry, square root both sides. So if they ask you for the nearest hundredth, let's say, right? This is a quick practice in rounding. The 7 looks to the next number, and that's going to kick it up to an 8 because it's over 5, or 5 or more. All right, so good enough on distance. Sorry I did not get to, midpoint, so I'll do that next.